Hello everyone, it's Michael again. So today we are going to do a lab demo to exploring data. In this lab, we will examine the data loaded from the vertebral column dataset that you downloaded in the previous lab. The objectives of this lab is after completing this lab, you will be able to explore and display statistics by using pandas, use charts to explore data characteristics. So this lab is going to be approximately 30 minutes or longer. So let's start into our first task. Accessing a notebook instance in Amazon SageMaker. In this task, you will open your Jupyter Lab environment and switch to Notebook to complete the lab. So to open the Jupyter Lab on the AWS Management Console, go to Service menu and choose Amazon SageMaker. So Amazon SageMaker. Let's click in here. And from the navigation menu on the left, expand the notebook section and choose a notebook instance. Okay. On the left, choose notebook instance. After that, look for the notebook instance named My Notebook. Open the Jupyter Lab notebook instance by going to the end of the row and choose Open Jupyter Lab. My Notebook. Open Jupyter Lab. Awesome. Now for the next task, what I'm going to do is we are going to open in a notebook in our notebook instance. So in this task, you will open the notebook for this lab. In your Jupyter Lab environment, go to the file browser in the left pane and locate the 2-3 machine learning file. Alright, that's the one, 2-3 machine learning file. Awesome. Open this file by choosing it. If a window appears asking you to select a kernel, select conda Python 3, then choose select. Then follow the instruction in the notebook. Okay. Alright. So let's follow in this note right here. So overview in this lab is the continuance of the guided lab in module 3 introducing business scenario. So you work for a healthcare provider and want to improve the detection of anomalies in orthopedic patients. You are asked with solving this problem by using machine learning (ML). You have access to a dataset that contains 6 biomechanical features and a target of normal or abnormal. You can use this dataset to train an ML model to predict if a patient will have an abnormality. About this dataset, this biomedical dataset was built by Dr. Henrique da Mota during a medical residence period in the group of applied research in orthopedics (GARO) of the Centre Médico Chirurgical de Réadaptation des Masseuse Lyon, France. Excuse me for my pronunciation. And the data has been organized into different but related classification tasks. The first task consists in clarifying patients as belonging to one of 3 categories: normal 100 patients, disc hernia 60 patients, spondylolisthesis 150 patients. For the second task, the categories disc hernia and spondylolisthesis will merge into a single category and is labeled as abnormal. Thus, the second task consists in clarifying patients as belonging to one of two categories: normal 100 patients or abnormal 210 patients. Attribute information. Each patient is represented in dataset by 6 biomedical attributes that are derived from the shape and orientation of the pelvis and lumbar spine in this order: pelvic incidence, pelvic tilt, lumbar lordosis angle, sacral slope, pelvic radius, grade of spondylolisthesis. The following convention is used for the class label: DH for disc hernia, spondylolisthesis SL, normal NO, abnormal AB. Dataset contributions. This data set was obtained from Dua D and Graph C into 2019. UCI Machine Learning Repository, Irvine, California, University of California, School of Information and Computer Science. Lab setup. Because the solution is split across several labs in this module, you must run the following cells so that you can load the data. Okay. Let's see. Step 1. Exploring the data. You will start by looking at the data in the dataset. To get the most out of this lab, carefully read the instruction and code before you run the cells. Take time to experiment. First, you will use shape to examine the number of rows and columns. Shape. You will now get a list of columns. Okay, so here it is. Now we get a list of column. You can see the 6 biomedical features. Let's run this. Okay, you can see the 6 biomedical features, and the target column is named class. Okay, right here, the target column named class. What column type do you have? Let's see. So we have different type here: 1, 2, 3, 4, 5, 6. You have 6 float for the biomedical features, but the target is a class. To look at the statistic for the first column, you can use the describe functions. Okay. To run this code and they give us the statistic. Challenge task. Try updating the code in the previous cells to view the statistic of all the features. Which features have outlier that you might want to examine? Because this data set has only 6 features, you can display the statistic of each feature by running the scribe in the entire data frame. Okay, so here it is. Are there any feature that aren't well distributed? Are there any feature with outlier that you want to look at? Does it look like there might be any correlation between the features? Okay, it's not always easy to make observation when you look at only at number. So you will now plot these values. So we import the matplotlib to see it. Let's see. You will now plot the distribution of the value for each feature by using the a density or kernel density estimation plot. So let's see. Here it is. It looks like a degree of spondylolisthesis lattices have a spike here compared to the other one. You will now plot the distribution of the values for each features by using a density or kernel density estimate KDE plot. So we will make plot and run our graph. Do any of the visualizations stand out? This one right here, I have a sharp density here, much sharper compared to other graph. Investigate the degree of spondylolisthesis. You will now investigate the degree of spondylolisthesis. Start with the density plot, which if you call show the distribution of the value. Here our density. The density plot smooth out the curve. It looks like there might be an increase around 400 right here. Visualize the data with a histogram. Okay. Using a box plot, you can see if there are any outlier. You can see a small increase around 400. Sometimes outlier like this can throw off training models. The only way to find out would be to test the model both with and without the outliers and compare the model's scores. However, this is a task for a later lab. You can see from the box plot that there seems to be a cluster above what look like the maximum. Is there a correlation between these data point and the target? Before you can look for a correlation, you will examine the target more. Analyzing the target, first, what kind of distribution do you have? It looks like you have about like 1/3 normal and 2/3 abnormal. This result should be fine, but if you could get more data, you would want to try and balance the numbers more. The class values are going to work for your ML model. So you will convert this column to a numeric value. You can use a mapper for this task, class mapper. You have this object. Now you can plot the degree spondylolisthesis against the target. Okay. So what do you see? Though there appears to be a link between the high values and the abnormalities, there are also many values that are in the same range. So there could be a correlation, but it's worth taking a closer look at the data. Challenge task is by using the previous cells, determine how the values of all the features correspond against the target. Visualizing multiple variables. As the previous step demonstrates, visualization can be very powerful. Sometimes you will want to analyze multiple data points. You can do this by using group by. Plotting out the feature for both abnormal and normal values side by side might help you observe any other differences. Using call function, you can create a correlation matrix for the entire dataset. And you can also plot out this data as well. By using the seaborn, you can visualize the correlation as a heat map. The challenge task is find all the data from the UCI machine learning repository using the previous code for reference and explore. And you have completed this lab. Now you can end by following the lab guide instruction. And that is pretty much it for today. Lab hands on. Thank you so much for watching and have a good day.